looking at oxygen, it is uniform. Now the first step for me to write this oxygen gas in covalent bond is to write them separately. I'll write my oxygen gas and another oxygen gas. Now keep in mind that oxygen on the periodic table has got 16 and 8. And we use the atomic number when we are dealing with bonding. So the second step here is to write the electronic configuration, which is 2,6. Now, when you are looking at chemical bonding, unless they specify in an exam, you will only consider the outermost shell. So we write only the outermost shell of this, and only the outermost shell of that. So we can see that we've used crosses here and dots here to show the difference even when we are pairing, so that we can see which ones have been shared. Now you must have learned in mathematics to say when you have two sets like this, which are attached at this point, this is the intersection. This represents numbers or elements found in both sides of the set. So if we are to share electrons as such in an oxygen molecule, we need to draw it as a set so that we can share those electrons and they can be found on both ends. So covalent bond always follows the rule of equal to equal, or eye for an eye. What do I mean? If I share one electron here, one must be shared here. In no event will such a thing happen such that you share two electrons from this one and one from this electron. Then you've lost your way. Another point to keep in mind is that since this oxygen molecule only needs 2 electrons to fill up its second shell, it means it will share those electrons to attain stability. So these 2 electrons will be shared because they are what are needed to balance out. So I'll share 2 electrons there from this one and 2 electrons there from this one. If I share these 2 electrons, 4 are remaining. This is what I will write up like that. And this side will be like that. And there you have your oxygen molecule of your chemical bonding. So I want you to write for me the chemical bonding in hydrogen